and welcome to Mirketa's webinar. My name is Indradeep Singh. I am co-host of this webinar. I will go with my introduction in a little bit while. Today we plan to do a 40 to 60 minute webinar on understanding how machine learning works. Um, the copy of webinar will be provided to you after the webinar is over. We will answer your queries and questions. If you have, you can post to us in the chat window available on the side of portal. We will discuss all the questions at the end of webinar. Agenda. Today agenda is to clear all your misconceptions about machine learning and to learn some basics to make a strong foundation in ML. We make you aware of some basic concepts and terminologies that we used in machine learning. Before that, I will talk about Mirketa's little bit so that you will know about who we are. Then we talk about our speakers with me. I have my colleagues that are co-hosting this webinar with me. So we start with what is machine learning. We will explain you with the definition of machine learning, its different types, with examples. Next, why do we have to learn? Okay, so before that, how machine learning is related to artificial intelligence and deep learning. This is the question which confuses lots and lots of people that what is the relation and difference between artificial intelligence, deep learning, and of course, machine learning. Next, we will discuss why machine learning and how it will improve the business. Then does it actually works? Because as we know that algorithms are just a set of instructions. So how it can learn from the inputs, data set, or from the past experience. Okay, so we will go through with that by undertaking an example of linear regression. Next, how to develop machine learning application. We will discuss the machine learning lifecycle, which is very important if you wanted to make or develop the machine learning application. As we are the Salesforce Silver Consulting partner, in last we will talk about Salesforce and machine learning. Let's start with first slide about us. We are Mirketa is a Salesforce Silver Consulting partner, headquartered in San Roman, California. We have another office in Florida, USA. Our global delivery center is in Noida, India. We are the Salesforce Silver Consulting partner. We are the Salesforce Silver Consulting partner. We do provide services in Salesforce on different clouds data and in business intelligence solution. We do build the AI chatbots for our clients. We do provide services for our clients on process engineering in customer service, sales, marketing, and HR areas. We did little bit work on and continue to work on custom app development and system integration on mobile services, force.com, .NET, and Java applications. So we can do any extension done on Salesforce. Okay, so getting deeper into our portfolio services. We provide our clients a service in strategy and architecture to delivery management. We do it all. Also, Salesforce provide implementation and integration services with different clouds like like on Sales Cloud, Service Cloud, Marketing Cloud, Community Cloud, and any other cloud that Salesforce have. We also did work with Heroku as our iPaaS platform to connect our machine learning models with Salesforce application, Delbumi, MuleSoft, Informatica as our iPaaS platform. We also provide data solutions to our clients with using the analytics for sales forecasting, marketing, and social area. As we discussed that we developed the applications on force.com, Salesforce One, Java, PHP, Python apps. We also provide delivery management by adopting the DevOps service. Okay, today I have my colleagues with me as co-host of this webinar. We all are machine learning and data science enthusiasts. We are the part of Mirketa as a machine learning developer. We have an experience on working with live projects of Mirketa like on Delphi and Alexa. So we have Anchal Gupta with us.
Hello guys.
In the deep, it's me. So hello and welcome again. Vipul Goyal. Hey. Vidit Khemka.
Hi guys.
And Monica Kashiramka.
Hi.
Now I request Anchal, my colleague, to start with their topic. What is machine learning?
Thank you, Indradeep. Now, my name is Anchal and I'll begin with what is machine learning. As you all know, humans learn from past experience and they give instructions to machine to follow them. Now, what if humans can train these machines so they can work faster according to them? Now, that is what is machine learning. For a definition, we can say that machine learning is a subdomain of AI, which provides systems the ability to learn and improve from the past experiences without externally being programmed. Now, for some examples of machine learning, we have diagnostic predictions, which are used by doctors. Then we have sentimental analysis of users, intentions, and reactions, which are used by tech giants on social media. Then we have online fraud detection, which uses natural language processing. Then we have virtual assistants like Google, Apple Siri, and Alexa. Then we have image recognition. Now I'll tell you about types of machine learning. We have basically three types of machine learning. First is supervised learning. In supervised learning, we have before training and then we apply that knowledge to the test data and we get the results. For example, we have this fruit example. Suppose we have a basket of fruits. We have different fruits. Now our goal is to categorize them into groups. Now, beforehand, we know the physical characteristics of this group. All these fruits, from their color, size and shape. Now let's say we take a new fruit. Now, we know beforehand its physical characteristics. By its size, shape and color, we can judge it. So suppose my fruit is round in shape and it's red in color and it has a depression on top. So I can easily characterize it as an apple and it belongs to the apple group. Now I'll tell you about unsupervised learning. In unsupervised learning, we don't have pre-learned data. We apply unlabeled data. For let's say example of a cricketer and a bowler. And we have to plot a graph between the performance of those bowler and cricketer and their wickets. And by that, we can easily cluster them as batsman and bowler. Now, I'll tell you about reinforcement learning. As you all know, reinforcement means providing some reward or maybe deducting some reward. Same example, in reinforcement learning, what we do is if we get our result and it matches what we expected, we provide a reward. Else, we give a feedback to the machine that it should predict until we get the desired result. For example, all of you must have played the snake game. In the snake game, your goal is to eat the fruits on your way. If you don't eat it, the snake will bite you if you take a wrong path. Hence, your goal is to choose the path so that you don't get bitten by the snake. That's your way to make the machine learn that you have to choose a way so that you don't eat the fruit and don't get bitten by the snake. Now, what is AI? What is artificial intelligence? Now, everyone is like, it is such a huge concept, such a huge confusion. Don't you worry. I am here to resolve your queries. AI enables machine to depict human intelligence. AI was coined in 1956. It is a pretty old but has gained a quite popularity recently because earlier we had data and which was so small we weren't able to predict accurate results. But now We have sufficient amount of data by which we can predict accurate results. For a definition, we can say that it is a technique which enables machine to mimic human intelligence. Or we can also say that it basically intelligence demonstrated by machines along with the natural intelligence displayed by humans. So, for example, let's say chess. Chess is a very good game you must have played. In that, we use algorithm to decide what best position you must use to reach and win the game. And we have Google Maps. All of you must have used Google Maps. You have to decide the best route to reach your location. Now, understanding deep learning. It's another concept in ML that you must all know. It works on the functionality of neurons. Now, neurons is a word which we all have listened somewhere in our previous time. Neurons are nothing more, but they are just the brain cells. Neurons are used to create a connections and to recognize a data pattern. Moreover, the more the data size increases, there are more neurons joined together. It helps in feature learning, which helps the system to do complex function mapping without depending on any particular algorithm or any particular learning. For deep learning, we have very two basic examples. For example, object recognition and handwriting recognition. We use tablets nowadays with a stylus, which helps us to do deep learning. Now, I'm going to tell you how machine learning and artificial intelligence are related. So, artificial intelligence is what when a computer algorithm does intelligent work, whereas machine learning, being a part of AI, learns from the data, also gathers information from its previous experiences and all the data it has been provided and helps the computer to behave accordingly and make changes. For example, you all have seen virtual assistants like Google, Apple Siri. What all they do? They are compared to help them arrange and track the data, which is implemented by the functionalities of artificial intelligence. But their actual modeling is done by machine learning, which gathers and refines this data based on users' participation with them. The way the user's voice modulation increases or its pitch is controlled. Another example for this can be the Tesla self-driving car. It's a very famous car. For AI, we can say that it uses the automatic self-driving, which uses object detection by recognizing video streams, which is the functionality implemented in AI. But for machine learning, we can say that it is trained by the human algorithms using ML. And Tesla is a car which just uses the feedback system. For example, it suffered an accident. So it learns from the accident and makes sure that it is not repeated again. Thank you. Now I would like to call my colleague Monica to carry on the further webinar.
So, thanks, Achal. Good morning, guys. I'm Monica here. So far, you have learned about the machine learning related to artificial intelligence, right? Now we learn about how machine learning related to deep learning. So some of the limitations of the machine learning give rise to the deep learning, right? One of the biggest challenges of traditional machine learning is feature extraction. Now, the term has been confused with what is features, right? In statistics, the feature is just a variable. But talking about artificial intelligence, they are nothing just a features, right? What happen is the complex problems, as you have just listened these words like object recognition and handwriting recognition, it becomes a huge challenge in the machine learning algorithm to solve. In machine learning, most of the features are needed to be identified by the expert and then hand coded as per the domain and their data types. Considering an example, take an image of a dog as being seen in the screen. The researcher need to extract the feature manually in the image of dog, like eyes, its nose, lips, and so on. Those extracted features are fed to the classification model. So the performance of the machine learning algorithms depends upon how accurately the feature is identified and extracted. Where talking about the deep learning solve this issue. In this, the feature extraction has been done automatically by the use of filters. So let us see how. The first layer of the neural network will learn the small details about the pictures. The next layer from the picture will combine the previous information to make the complex information. In the neural network, the feature extraction is done with the use of filter, as I already said. The network applies a filter to the picture to see if there is a match. That is, the shape of the feature is identical to the part of the image. If there is a match, the network will use this filter, okay? And the process of the feature extraction is done automatically. I hope things are get clearing to you. Now let's move ahead towards and let me summarize all these three terms: artificial intelligence, machine learning, and deep learning for you. To summarize as a whole, we can say that artificial intelligence is a technique that enables a machine to depict the human behavior. On the other hand, machine learning is a subset of a technique which uses statistical method to enable machine to improve with experience, which probably means that it uses algorithm to pass the data, learn from the data, and make the informed decision what it has learned. Now, this deep learning is a subset of machine learning which makes a computation of multi-layer neural network feasible, which means that this algorithm uses layers so that it can learn and make the intelligent decision on their own. So many of the companies which were failed without using the machine learning, let me ask in this way, all of you use cameras, right? Which one is your favorite? Canon, Nikon? Do I have the Kodak fan here? Okay, let me ask in this way, how many of you have been the fan of those old fancy looking cameras from the Kodak? No doubt the cameras were one of the best then. It was a company that dominated the photographic film market during most of the 20th century. But they blew their chance to lead the digital photography revolution as they were in denial for too long. What's the reason behind it, guys? Evolving technology from the Kodak failure to cope up with it. Everyone here has a smartphone, right? Like Apple, Samsung, Xiaomi, Vivo, Lenovo. Okay. And yes, not to forget about the business phone manufacturer BlackBerry. Nokia has everything except innovation. Yes, innovation that gives you a lead over others. But Nokia learned their lesson and now is going to the right direction, I guess. Today, with the rapid technology advances, machine learning has found practical application in the fields of healthcare, robotics, and of course, mobile and webcams. So now talking about the companies that are currently using the machine learning is Amazon, which uses the artificial intelligence to create the recommendation system. ACES knows exactly how you are going to spend with them over the course of your lifetime. Otto uses the algorithm to cut down the stock and predict what people will buy in the next month, right? And the Salesforce, it's probably to be expected that the world's leading sales platform is very active in acquisition. One of the machine learning system Salesforce was keen to highlight the last year was so-called as Einstein technology, which is set to analyze every aspect of the customer relationship with a particular company. On another hand, Apple, in spite of many ups and downs, emerged as a great leader in the mobile manufacturing industries. What are the factors that plays the important role in Apple's success? It's the addiction to the customer experience that may be creating the loyalty, customer loyalty. Attention to the details drives the excellence, and the constant innovation, which drives completely crazy competition because of speed. The companies like Bedu, which has launched their chatbots like Kit.ai and the voice-based recognition systems, which are highly interested in NLPs. NLP means here natural language processing, with the view of developing a workable voice active search function. Company, talking about the company like Qubit, is a company which uses machine learning to choose the items in the interest of the social media fields and try to find shoppers which are more likely to buy it. Now the question that comes in the mind is how machine learning can improve the business. Guys, AI is a hot topic at the moment, but most of you don't have a clue or of the implications of it. You are probably interacting with artificial intelligence more than you already realizing it. It decides whether the email is spam or not, whether you are qualified for the loan or not, or dating app also use it for finding the good match. Also to Spotify, which enables you to listen to the music. Training an algorithm to predict the future outcomes to learn more about your clients, and also to analyzing 650,000 lives to cluster clients into different segments. That's the use of the machine learning. Artificial and machine learning are going to change your role as a manager or the marketer. It allows you to be much faster and make use of the bigger data set, including that of your competitors. You will be able to make predictions, correlations, and understand which efforts give the highest rate of interest. You will be able to discover habits, opinions, and attitude of your customer using the machine learning. It helps you to know more about your customer, like how does it feel about your product, how he spent his or her lifetime, and which of your visitors is most likely to buy your products. So many of you might be thinking why machine learning becomes the future, or why it becomes the buzzword in these last 2 to 3 years, right? I think the biggest advances you are seeing is largely due to the techniques that are used in the deep learning. The deep learning has been around for many years, but they weren't much effective. For example, like Google Translation are using our deep learning. The translation quality improvement in the last years is bigger than what we can see in the last 10 years, guys. So I think advancement in the machine learning will make a big difference in many, many fields. So now the thing is, what were the issues that makes a machine learning come to existence? Let us discuss them one by one. In the field of statistics, the problem was how to train such a large complex data. In the field of artificial intelligence and computer science, the problem was how to train most robust version of artificial intelligence systems. While in the neuroscience, the problem is how to design the operational model of these brains. Now, to solve these problems, machine learning comes to existence. Thank you for hearing me. Now I request our next speaker, Vidit, to proceed further and continue this session.
Hi guys, so now we are learn how machine learning works. So we take the basic example of machine learning, which is linear regression. But before knowing what is linear regression, we understand what is regression. So regression is a statistical technique to predict the relationship between two or more variables. The variable which is gonna to be predicted is called dependent variable, and the variable which are used to predict the dependent variable are called independent variables. And now we understand linear regression. Linear regression is a type of regression analysis where we want to find the relationship between some data which are dependent and independent. As we can see from the graph, there are some data points, and here we predict a linear relationship between them. So this blue line is called the best fit line or the regression line. So now this line is governed by a equation which is y equal to wx plus b, where y is dependent variable, x is independent variable, w is the slope of the line, and b is the y-intercept of the line. Alright, so now it is the time to test our model. So for testing any model, we need some data. So let's plot some data here. Alright, so now our data should plotted. Now it's time to plot our regression line or best fit line. As we can see that our line is plotted, so it's time for prediction. So now we predict our value. So this is our estimated value, and this is our actual value, and we can see that there is a huge gap between them, which is the error. And our goal here is to minimize the error between the estimated value and predicted value, or and actual value. So in other words, the main goal here is to minimize the error, that is the distance between actual value and predicted value. Now see this in action. So we need to plot our best fit line. For that, here are some data points, and we need to draw a line which is has the minimum error between the predicted and the actual value. So we draw a line here. Now it's time to give it some more data to check its accuracy. As we can see that the error of our line can be further minimized by changing the value of slope and intercept, which is our w and b parameter. So let's make some changes and now predict a new line. So as we can see that our new line has less error than the previous line by changing the value of slope and intercept. So this is the main idea how machine learn from data. So we repeat these steps again and again using a random initialized weight, and then we need to find a more optimal value of w than the current one. So we calculate the slope at the current point, which is called gradient, and from gradient we find the more optimal value of w than the current one, and then we will change it to optimal value. And after that we again apply gradient descent to it, and then find the more optimal value than the current one, and then change that, and then we repeat this step again and again until we find the global minimum cost here. So this algorithm is used to find the most optimal value of w and b. So this is the main idea behind and the basic tutorial of how machine learning works actually. So I request my colleague Inderdeep Singh to continue further. Thank you.
Thanks a lot, Vidit. For future machine learning developers, how to develop the machine learning applications. To develop the machine learning applications, first you must have to clear your theoretical concepts on machine learning, and you must have to learn one programming language. But the common part is you have to follow the machine learning life cycle to develop the machine learning applications. So you must have to understand the stages of machine learning application, the role of data stage, and the technical tools that you have to do uh, to make the machine learning application. So we will discuss about the stages, the roles of different data science team members, and the technical tools that you have to use at each stage of machine learning life cycle. So the various businesses use machine learning to manage and improve their operations. They can vary with scale and complexity, but their general structure is the same for developing the machine learning application. That is planning, data engineering, data set splitting, modeling, and in last, the model deployment. So these all five are stages in machine learning life cycle that you have to follow to make machine learning applications. These all stages will go under evolution for any update and for bug fixing. Okay, so let's see the stage one of machine learning lifecycle, that is planning. So in the first phase of machine learning project realization, company representatives outline their strategic goals. They assume a solution to a problem. They define a scope of work, and also they plan the development of all machine learning model. So in this case, chief analytics officer. Chief analytics officer suggests applying personalization techniques based on machine learning. Business analyst defines the feasibility of a software solution and sets the requirement for it. Solution architect organizes the overall development. Also, you must have to care about the budget that you going to spend on different resources like technical experts, iPaaS platforms, data storage, processing, and etc. That you need to develop the machine learning application. Okay, the stage two of machine learning life cycle is data engineering. As we know that data. Okay, so as we know that the data is the foundation of any machine learning project, and the data engineering is the complex and involves data collection, visualization, labeling, selection, formatting, cleaning, sampling, and many other things. Okay, so each stage of data engineering further split into the several steps. As we can see in data transformation, it's split into scaling, decomposition, and aggregation. The one fact about data engineering is the majority of budget, around 80%, is spent upon data engineering tasks in machine learning applications development. The machine learning model is dependent on data and lots of data and the right data. If the bad data goes in, what the model learn is noise. As we can see, data engineering is generally divided into data preparation and data pre-processing. So first, I will explain you about data preparation. In data preparation, we prepare or transform our raw data into a form so that it can be processed further in machine learning model and can be used for analysis, because and algorithms need data in the compatible form. The first step, as you can see under data preparation, is data collection. It's a task of data analysts to pick up the pattern and lead the way to find out the different ways and sources of collecting relevant and comprehensive data, interpreting it, and analyzing the result with the help of statistical technique. There is no exact answer to the question how much data is needed, because each machine learning problem is unique. The more and better is reasonable for this phase. The some data scientists suggest that considering the one-third of collected data may be useful. To collect data, you can launch your personalized campaign on Google Analytics. You can also download and use data from the sites like Kaggle. You can also take data from GitHub contributors. AWS also provides data, and the skills on SQL will be preferred for that. So after data collection, the step under data preparation comes is data visualization. It starts after collecting data, but goes parallel with each phase. Means you have to do data visualization before data labeling, after data labeling, and after data selection, data transformation, and for all. If you are a Python developer or R developer, you can use these all modules for the task of data visualization. So after data visualization, what come is data labeling. As we already discussed, supervised machine learning, that we will train a predictive model with historical data with predefined answer. That predefined answer are known as labels, and rest of attributes are features. So sometimes our data have missing values for these labels or predefined answers. So mapping this missing target attributes in a data is called data labeling. So for data labeling, you can use outsourcing, can acquire a domain expert, or you must have seen capture challenges in the Google. So this is also a task of data labeling, which is provided by Google for image recognition. So after data labeling, what's come is data selection. So after having collecting all the data analysts choose a subgroup of data to solve the defined problem. So the objective of this step is to train data with best features and attribute, or making the data compatible with your all algorithms or according to your resources. The next part, as you can see, of data engineering is data preprocessing. In this phase of data engineering, we structured and clean data to allow a data scientist to get more precise results from an applied machine learning model. This technique includes data transformation, in which we transform data through scaling. The scaling shows that data must have numeric attributes that span different ranges. So it's like changing the scale from meters to kilometers, or from 1 to 10 to in between 0 to 1. So it becomes feasible for processing and for analyzing tasks. The next data transformation is to decompose the data and aggregate the different data. So another step that comes under data preprocessing is data formatting, data cleaning, and data sampling. Data formatting standardizes the record format. Data cleaning removes the unwanted data, and data sampling. Data sampling means you are selecting a smaller portion of data to start with. So the third stage of life cycle is data set splitting. So after the data engineering, we split our data into the subsets. So generally, we divide our data into the training set and test set. The training set contains the parameters, the attribute or feature, whatever you can say, that model has to learn from. And the test set have data, and their purpose is to identify the pattern in new unseen data, or to check the accuracy or error in results. So we can also divide our training set into the validation set. The purpose of validation set is to improve the machine learning model by making the fine adjustments in the weights or hyperparameter. As the Vidit explains, that if you are using the linear regression in which have an equation y is equal to wx plus b, so finding the value or tuning the value of these weights w and b will be done if you put some unseen data that comes under the validation set, the test set, as I explained already. The second last and the fourth phase of life cycle is modeling. During this stage, numerous models to define and The one of them which gives the best result will be taken for the final implementation of model and for the deployment. So during so one of them provides, as I said, that the one of them that provides the more accurate predictions will be selected. So in modeling, first what comes is model training. So you may have to feed your machine learning model or algorithms with different data sets, and algorithm will process data and output some model that is able to target value in new data sets. So when you provide the input, you get your answer of your predictive analysis or for the classification problem. So model training is that basically divided into the supervised and unsupervised learning. Supervised learning is used for the problems like classification and regression. The unsupervised learning is used for for the models that are using the algorithms of clustering, decision tree, and of data set of data reduction. Also in modeling comes is model evaluation and testing. The best technique for doing this is applying the cross validation. We will discuss all these technical terms in upcoming webinars or some series. So you can all then you also have to improve the predictions with assemble methods like bagging, boosting, and stacking. The bagging we used to reduce the variance error. Boosting, each model is trained with data, so that receive trained with the data that received from the previous model performances. The stacking we use to reduce the generalization error. So we will explain you these techniques in more details in coming webinars. The next tools that you can use for modeling. The some companies or modules have already pre-trained models and have some APIs functions to make and train and validate this data. So some of these modules are TensorFlow, PyTorch, Scikit-learn, which are mostly used in the industry. Okay, so the next and the last stage is model deployment. Model deployment means you're going to put your model under the production use. So before putting to production, you may have to convert the final model from some higher level languages like R and Python to lower or native languages like Java, C, C++, so that it become compatible with the production environment. So after deployment, you can perform the alpha beta testing. I will prefer machine learning as a service is the best way to deploy your model on cloud platforms like Google Cloud AI, AWS, Heroku, or another services which are cloud integrated. So the benefit of machine learning as a platform is it provide a semi-automated automated service for data preprocessing, model training, testing, and deployment. Also, you can connect your results of model with your application via REST APIs. It's very simple. Okay, so you should also think about how you need to receive analytical results in real time or in set intervals. On the basis of these options, you can think about your model deployment according to your results that are if you need results via batch predictions, real-time prediction, or web services. The web prediction deployment option is appropriate when you doesn't need your prediction on continuous basis. The real-time prediction option if you need to analyze the live streaming data, or a web service which provide you the real-time forecasting. The difference between the real-time prediction and web services is the time taken by the system to analyze the results. Okay, so now I like to request our senior Salesforce and ML developer, Vipul Goyal, to continue with Salesforce and machine learning.
Thank you, Inderdeep. When it comes to Salesforce and machine learning, the first question that comes into mind is that does Salesforce provide any of its functionality to leverage machine learning and AI? Yes, it does. It provides Einstein analytics, but it will cause you some bugs. But when it comes to hosting your custom models on Salesforce, is it possible? with the amount of enforces with the amount of limitations that Salesforce enforces, it's nearly impossible. So how can you use a custom model with Salesforce? It's quite simple. You can simply host your custom model on different cloud platform or web hosting platforms such as Heroku, AWS, GCP, Microsoft Azure, and all, and then use REST APIs and callouts to simply integrate with Salesforce. We have done this in one of our products, that's Delphi. You can use Delphi to see how easy it is to connect to different opportunities, rank them, rank them, and see which sales rep is recommended for your opportunities. By using this, you will get to know about what actually a custom model does when integrated with Salesforce. This is from our end. We rest our case. Now the stage is open for questions. You can type in your questions in the chat box that you see on your screen. Okay, I see a question here. It's about gradal descent and learning. So it's that the question is, what is the perfect value for learning rate? See, it's quite clear that when it comes to learning rate, there is not a we cannot assign a perfect value to it. It's based on the algorithms and based on the pre-processing that you do. It can vary from person to person. For me, it's 0.005, but it may change according to different algorithms and pre-processing.
So now another question comes here, which is, what if our data is nonlinear? Which type of regression analysis we use here? So the answer to this question is that there are different kind of regression analysis, and we can use polynomial regression to find the relationship between dependent and independent variables. So
Okay, I see a question here. The question is, are divided the data into validation set will correctly validates the machine learning model? Okay, so thanks for question. I said no because validation is not for the validating purpose. It's just we can say that it's just a tuning technique to improve the hyperparameters to validate the model. You have to check the accuracy, mean square errors, and also have so many parameters. So the true accuracy of the model, as I explained by cross validation, have to change the and then you have to change the model to get the minimum error values, and by that you can validate your model. But the purpose of validation set is just to put your model to the unseen data to tune the parameters of your model.
So we have another question. It is, what is labeled and unlabeled data? So basically, we use this term when we're explaining supervised and unsupervised learning. Unlabeled data is basically consists of samples of natural, basically human created artifacts. There is no as such explanation for those terms. It basically a data. It can be any photograph of anything. Like we use the example of cricketer and bowler. So cricketer and bowler, they are unlabeled data. And for when you say a label data, it's basically a set of unlabeled data which we have augmented and we have provided a tag or label. For example, that fruit example we took, so we provided an apple tag to the fruits which look like apple.
So one of the question arises is, what is neural network in artificial intelligence? In artificial intelligence, the neural network is an emulation of the biological neural system, which receives the data and process the data to gives the output based on the algorithm and empirical data.
Okay, guys, do you have any other question? Okay, I see one more question, which says, how do you handle text data? See, there are different methods to handle text data. As we all know that when it comes to computers, it doesn't understand text. It only understands zeros and ones. So to handle text data, if I talk in terms of our language, Python language, so yeah, do it using label encoders and one hot encoder, TF-ID vectorizers, but it depends on the amount of data we have, the space we can use, and the CPU and GPUs available. That's it. Do you have any other question?
No, okay. So thanks for joining us. We provide you the copy of this webinar through a link to your email boxes. So thank you guys so much for joining us. We are